So welcome to Sprouts of Science YouTube channel. Myself Kumar Ramawat. So today in this class we can discuss about organic chemistry. So from this video we can discuss majorly focus on organic chemistry. So first of all I teach you first year organic chemistry, later I teach you second year organic chemistry continuously. Later we can go with physical chemistry and last we go with inorganic chemistry. I hope you understood. Okay. Today let me start the class. Introduction about the organic chemistry. So आज की चैप्टर है organic chemistry, very important. So the weightage in need it may be nearly 18 to 20 question. 18 to 20 question will be coming NEET exam. Okay, I will give you notes. Write the notes completely, very important. Okay, I will give you complete notes. So first of all, if we talk about definition of the organic chemistry, let me go through that. For example, let me see here. Organic chemistry actually you can see in class 11th and class 12th. In class 11th and class 12th. So what is in class 11th and what is in class 12th? Let me see. In class 12th, you can discuss about basic concepts, okay? And you also discuss about IUPAC. IUPAC is nothing but naming, how you can name an organic compound, that you also discuss. And you also learn about isomerism. Isomerism also discussed. You also read about GOC1 and GOC2. GOC1 and GOC2 also you can discuss here. And we also discuss about experimental chemistry. Experimental chemistry or qualitative quantitative analysis also same that you discuss in first year. These are the first year major organic chemistry topics. First is basic concept you can discuss, and next you can discuss about IUPAC naming, you discuss about isomerism and GOC1, GOC2, and you also discuss about experimental chemistry. Come to second year is very important. In second year, you can discuss about majorly derivatives of organic compounds. Derivatives of organic compounds. If you see there, like haloalkenes, alcohols, ethers, aldehydes, or we can discuss about carbonyl compounds, and amines, and we discuss about polymers and biomolecules. These majorly we discuss in the second year organic chemistry. Okay, I hope you understood that is what is in first year organic chemistry and second year organic chemistry. Today we focus on majorly basic concepts of organic chemistry. Next video we can discuss about IUPAC naming. Okay. So first of all, what is the definition of the organic chemistry? Let me see. If we talk about definition of the organic chemistry is a branch of chemistry which deals with the organic compounds, their structure and their properties. How we can discuss now? So the definition. So the branch of chemistry that deals with the study of organic compounds, structure and their structure and properties. So see here the definition. The definition is nothing but it is a branch of chemistry, right? It's a branch of chemistry that deals with the organic compounds. Their structure and properties. Like what is meant by organic compounds here? Organic compounds are nothing but the compounds which having carbon element. So the first point, the second point is, so organic compounds are the compounds having carbon as the basic element. So see here, organic compounds are compounds having carbon. Here is nothing but carbon as the basic element. In the compound which having carbon as the basic element, those compounds are called as organic compounds. For example, if I talk the example, let you think that is, if you think this is the example, I am writing like this. If you see, it is an organic compound actually. It is a organic compound. If you see its name is hydroxy benzoic acid. Ortho-hydroxybenzoic acid. So commonly it is called as salicylic acid. It is used as a medicine. Salicylic acid in dermatology. In dermatology, it is used as a medicine that is called salicylic acid. Its IUPAC name is ortho-hydroxybenzoic acid. If you see here, you can find carbon here, right? So here also one carbon is existed. Here also one carbon is existed. Here also one carbon, and carbon. So here carbon is a basic element, right? Here in this compound, carbon is act as a basic element. Then we can conclude that is this compound is an organic compound. This compound is an organic compound. So I hope you clear the definition, that is organic compounds and the compounds in which carbon is a basic element. Carbon is the basic element. So now we discuss some compounds are there, they has even carbon as element, but they are not the organic compounds. What I am saying that is, we have discussed that organic compounds are compounds in which carbon is a basic element. But in some compounds, carbon is act as a basic element, but they are not the organic compounds. Let me see that is. What are those compounds? I hope you can note these all points. Very important, all these points. You can prepare a clarity notes, right? Yeah. I hope you cleared all these points. Okay, let me go to the third point. Here the third point is, some compounds are there in which carbon is act as element. So the third point is, in some compounds, carbon is present, although they are not the organic compounds. So in some compounds, carbon is present, although they are not the organic compounds. They are not the organic compounds. Very important, these statements. If they ask like this in examination, that is, which of the following is not an organic compound, they can give different compounds, and each compound has a carbon element. In every compound you can find a carbon element. So we know that basic thing, that is, in the compound which has carbon element, we can conclude that as the organic compound, right? But some compounds are there, in the compounds carbon is present, although they are not the organic compounds. If you see the examples are the first like CO2. CO2 is called carbon dioxide, right? CO, carbon monoxide, and Na2CO3. This is called as the washing soda, and NHCO3, baking soda, and you can find Cl and NC and CNO and NCO. Here CO2 is called as carbon dioxide, right? And CO is called as carbon monoxide. Na2CO3 is called as washing soda. NHCO3 is called as baking soda. And CN is called as cyanide. This is called as cyanido. This is called as cyanido. NCO is called as isocyanido. You can see here, if the first element is a carbon, in CN the first element is a carbon, then that is called as cyanido. If that is the reverse, means first is a nitrogen, later this is a carbon, this is called isocyanido. What is that? Isocyanido. Here cyanido, isocyanido. What about CNO? Here CNO is called as cyneto. Here to is there, here do is there, different, right? Here this is called isocyanato, right? Isocyanato. Remember this. These are the compounds in which carbon is there. You see here in this compound, here this is the carbon, right? Carbon. You can find carbon. You can find carbon here. You can find carbon, and carbon. Although they has a carbon, right? But they are not the organic compounds. These are the inorganic compounds. Remember these compounds, very important. Okay. Now, what is the basic organic compound, or what is the simplest organic compound? Let me see. So the simplest organic compound till now, that is hydrocarbon. So hydrocarbon is the simplest organic compound. The simplest organic compound contains carbon and hydrogen. hydrogen called what is called? Hydrocarbon. That is called hydrocarbon. So here the simplest organic compound contains carbon and hydrogen, and that is called as hydrocarbon. What is hydrocarbon? If you see, that is, if I talk about propane, I am taking just example propane. What is my propane? You not understand now. So later when we talk about IUPAC, you can completely understand about it. Just remember now. Okay. So I am talking about example, that is propane. Propane is one of the hydrocarbon. So how can you say that propane is a hydrocarbon? If you see here clearly, if I talk with the structure of the propane, it will be like this. This is the structure of the propane. This is the structure of the propane. So actually it is a line structure. What is called? This is a line structure. And how we can identify means prop, which means 3 carbons. Here prop, which means 3 carbons. Actually you can have methane means 1 carbon, meth means 1 carbon. Okay, you have like this, so different meth, eth, prop, but, pent, hex, hect, act, non, dec, like this. Based on number of carbons you can determine that. So here prop means 3 carbons are present. So see here 1 carbon is existed, here 1 carbon is existed, and here 1 carbon is existed, right? So actually carbon has a special property that no one element has. Hence the carbon is called as the king of the all elements. King of the all elements. It forms number of compounds. It forms number of compounds due to it has catenization capacity. Catenization capacity that the carbon has, due to catenization capacity and due to tetrahedral shape, it can form the many compounds. Hence it is called as king of elements. That also we can discuss in detail the reasons of that. So here actually the carbon has a 4 valency. How much valency? 4 valency. 4 valency means it forms 4 bonds. It forms 4 bonds. If you have the if you take the periodic table, in periodic table the carbon is situated in 4th group. Hence it has 4 as a valency. If you talk about nitrogen has 5 as a valency, like that. So if you see here, carbon has how much valency? 4 valency. 4 valency means here it can form 4 bonds. Kitna bond form करते हैं? 4 bond form करते हैं. Kitna bonds? 4 bonds. If you see here, let you think the carbon, first carbon, let you name it. So the first carbon, it is the second carbon, it is the third carbon. It is the first carbon, second carbon, and third carbon. If you see here clearly, in first carbon, I said that is each carbon form 4 bonds. So the first carbon formed single bond with second carbon, right? The first carbon formed single bond with second carbon. So here how many bonds are formed? Only 1 bond is formed. So there is a possibility of forming how many bonds? 4 minus 1 means 3 more bonds were formed, and that 3 more bonds were formed by the hydrogen. Here 1 hydrogen is existed, here 1 hydrogen is existed, here 1 hydrogen is existed, right? This is about first carbon. Now come to second carbon. So second carbon is formed 2 bonds, right? 2 bonds with the first carbon and third carbon. And how many are remaining? 2 more bonds will remain. So here 1 hydrogen and here 1 hydrogen. Come to third carbon. The third carbon is almost similar to first carbon, which means the third carbon also formed a single bond with the second carbon. And how many were remain? 3 were remain, and the 3 were the hydrogen bonds. Here you can see 1 hydrogen, here you can see 1 hydrogen, here you can see 1 hydrogen. Now see here, how many carbons are there? 1, 2, 3. 3 carbons are right. Okay, how many hydrogens are there? 1, 2, 3. 1, 2, 1, 2, 3. So 6 plus 2, how much? 8. C3H8 is called propane. It is called propane. It is one type of an alkane and it says the hydrocarbon. It is a hydrocarbon, which means it has only carbon and it has only hydrogen. So the simplest organic compound till now, that is a hydrocarbon, which has only carbon and hydrogen. If we talk example is the propane, we have methane, we have alkane, and we have different compounds. In IUPAC we can discuss about them. This is the about few points regarding organic chemistry. So in some compounds carbon is present although they are not the organic compounds. Example, carbon dioxide, carbon monoxide, washing soda, baking soda. Okay, you have cyanate, cyanato, isocyanato, cyanato, isocyanato. And the simplest organic compound contains carbon and hydrogen called hydrocarbon. Example, propane. Right? Now we go to fifth point. So here in organic chemistry, I said we can discuss about organic compounds, right? We can discuss about organic compounds. And what are those organic compounds? So the organic compounds are majorly different types are there. If we talk, we have now only we talked about hydrocarbons. Not only hydrocarbons, we can find different compounds like derivatives of the carbon compounds. You can see here the fifth point, right? So in organic chemistry, we study about organic compounds. We study about organic compounds, and we discuss about hydrocarbons. And their derivatives We discuss about their derivatives. What is that? In organic chemistry, here that is talking about chemistry. Right? In organic chemistry, we study about organic compounds, hydrocarbons, and their derivatives. Here, what is my derivatives? Let me focus. So if you think simply, I am taking CH4. It is an organic compound and it's one type of hydrocarbon. But I am taking CH4. You may not understand now about what is CH4, everything. You can discuss about it later. You can just remember now. Okay? I am taking what? CH4. I said if they have in a compound, if there is only single carbon, then that is called as methane, right? Methane. It is a methane. Have you understood? Now what I am doing means, in this methane, I am using, if this is a methane, right? This is called methane. It has one carbon and 4 hydrogens, right? It's one carbon and 4 hydrogen. It's one type of a hydrocarbon. Now what is about derivative? If you see here, I am removing one hydrogen. What I am doing? I am removing one hydrogen. And I am adding OH. What I am doing? I am adding OH. It becomes CH3OH. And it is called alcohol. And what type of alcohol means? It is the methanol. This is called methanol. This is methanol. You see here, methane. When in addition to alcohol, it becomes a methanol. It is a derivative. Here, hydrocarbon was converted into alcohol like this. Similarly, instead of CH4, what I am doing? I am neglecting minus hydrogen. I am removing one hydrogen. What I am doing means now I am adding the oxygen. What I am doing? I am adding the oxygen. Now what happened means H C double bond O H. C double bond OH means I am removing 2 hydrogens. This is called as aldehyde. What is this? Is aldehyde. This is called aldehyde. This is called formaldehyde. Like this, aldehyde we can gain the we can get alcohols, so on like this. We can get the alcohols, we can get the carbonyl compounds. What we get? Carbonyl compounds. We can get carboxylic acids. We can get amines. You just remember the derivatives majorly are the alcohols, carbonyl compounds. Again, in carbonyl compounds we have aldehydes and ketones, and we have carboxylic acids and we have amines. These are the major derivatives of the organic compounds, which means hydrocarbons. I hope you got a clear point. Okay, now one more point, that is, so what we call the carbon is called as the king of the all elements. Why it is called the king of all elements? It can form massive compounds. It can form many compounds. If you have studied in 10th class, right? In 10th class you can study about Buckminster Fullerenes. It has nearly 80 to 90 carbons. Thus much big compounds also formed by the carbon. The reason is, there has a 4 reasons. What are the reasons also we can discuss, okay, later. So I hope you got the clear point. In organic chemistry we study about organic compounds, hydrocarbons and their derivatives. So derivatives are the alcohol, carbonyl compounds, carboxylic acids and amines. These we can discuss in second year, right? We can discuss in second year. Now, very important, we can discuss about the 3 to 4 scientists' name and their contributions to organic chemistry. We can discuss now. Very important, that one. First of all, so what are the organic compounds we are discussing now? One scientist named Berzelius. He said that is organic compounds cannot be synthesized in laboratories. Organic compounds cannot be synthesized in laboratories. They are only synthesized in nature. The reason that is due to some mysterious forces. He said due to some mysterious force. And he proposed a theory called vital force theory, VFT theory. We can discuss that is. So, Let me think. Taking point like this. In 18th century, in which century? 18th century. The scientist named Berzelius. What the scientist named Berzelius. Berzelius proposed VFT. For that VFT, which is nothing but vital force theory. How you can write? He proposed vital force theory. This is called VFT. So according to VFT, so organic compounds cannot be synthesized in laboratories because of due to some mysterious forces, very important statement. What this statement means, the scientist named called Berzelius is a scientist. In 18th century, he proposed a theory. That theory is called as vital force theory. What that vital force theory, which is called VFT. According to this theory, what it says means, so according to VFT, organic compounds cannot be synthesized in laboratories. In laboratories, the organic compounds cannot be synthesized. The reason that is some mysterious forces. If you think an organic compound, it is an organic compound. To synthesize this organic compound, it requires some forces. And that forces are some mysterious forces, and that forces only exist in nature. So we cannot, we cannot establish such forces in laboratories. Hence, the organic compounds cannot be synthesized in laboratories. Was biggest statement was given by the scientist named Berzelius. So many of the scientists also believed that the statement which was passed by the Berzelius was true. But later, in 1828, the statement gone wrong. What that and who made it gone wrong? Let me discuss now. So I hope you got clear point regarding this. Now, a scientist. In 1828, I think, in NCERT, the scientist name was also given, what he was done, everything is very important, what is given in this NCERT. So, in 1828, in which year? 1828, name of Friedrich Ohl, the scientist is Friedrich Ohl. So, in 1828, Friedrich Ohl prepared or synthesized organic compound. The organic compound is urea. In laboratory from its inorganic compound. That inorganic compound is ammonium cyanate. For that organic compound, inorganic cyanate, ammonium cyanate. So here the first scientist. So here you can write the first. So in 1828, Friedrich Ohl synthesized the first organic compound. So in 1828, Friedrich Ohl synthesized the first organic compound called urea in laboratory from its inorganic compound called ammonium cyanate. So according to Berzelius VFT theory, vital force theory, he said that is the organic compounds that cannot synthesize in laboratory. But the scientist named Friedrich Ohl made it wrong. So by synthesizing the organic compound from its inorganic compound. Here the inorganic compound is ammonium cyanate and the organic compounds are urea. I hope you all knew about urea. Your fathers mostly are the farmers. The farmers means in agriculture background, they will sow that urea in the fields, right? So the urea is an organic compound. Let me see. Here the ammonium cyanate formula is NH4CnO. This is called ammonium cyanate, and it is a inorganic compound, right? It is a inorganic compound. So on heating it, on what in doing? On heating it and rearrangement. What happened? A rearrangement was took place. Rearrangement. It's nothing but just what are the elements are present within this compound, they get separated, they get arranged due to heating. So when he heated, it is an unexceptional discovery. So he not majorly done so to synthesize only organic compound while he working on ammonium cyanide. So unexpectedly, so urea was synthesized. Urea was synthesized. Not it was basically it was unexceptional. Okay. So it is the ammonium cyanide, right? Inorganic compound. So from this inorganic compound, the organic compound called ammonia was synthesized. The ammonia formula is H2N C double bond O NH2. NH2. This is called urea. Or this is called urea, and it is a organic compound. What is this? This is a organic compound. I hope you understood. So initially we have NH4CNO. It is what is this? This is an inorganic compound called ammonium cyanide. So on heating it and rearrangement on this, we have got urea, which is called organic compound, and the formula is H2N C double bond O NH2. You can see here the majorly you can find the same formula. The formula was same, and we can take here 2 modes. That's it. The nitrogen was twice we can take. That's only the difference. The major difference was not existed. I hope you got a clear point regarding the urea. I hope, right? So the first scientist named Friedrich Schuler synthesized the first organic compound called urea in laboratory from its inorganic compound ammonium cyanide. Ammonium cyanide, right? So here we have 2 nitrogens. Here have only single nitrogen. Why there is a difference means if you on doing it what you called balancing, right? In 10th class you may read about balancing. So on balancing the equation you can get the clear regarding it. So this is about in 1828 discovery. Again in scientist named 1848 scientist Goldway or the scientist. So he is the first scientist. He is the first scientist. The second scientist in 1848, right? So not 48, in 1845. In 1845, the scientist named Goldway. Who is the scientist? Goldway. Goldway synthesized first organic compound from its elements in laboratory, right? So here also I use the term first, here also I use the term first. And what the difference means, this first is due to the organic compound synthesized from inorganic compound. Here the scientist named Friedrich Schuler synthesized the organic compounds from inorganic compound. But when you come to the Goldway in 1848, he synthesized the organic compound from its elements. Then you want to understand the question, that is whether they are asking about inorganic compound or its elements, right? So what it means, he synthesized the organic compound named acetic acid. What is this? Acetic acid. So the formula is like this. So when he combined 2 moles of carbon with 2 moles of hydrogen and oxygen on heating it. Okay, I will write the red pen. Red marker, not pen, right? So 2 moles of carbon plus 2 moles of hydrogen plus O. So on heating it, he got 2 moles of CH3COOH. CH3COOH. You can write in well, you can write like this: CH3C double bond O OH. Okay, this group is called as carboxylic acid group. We can discuss about derivatives of the hydrocarbons, and also we discussed about carboxylic acid, right? This is called acetic acid. So in we have IUPAC. In IUPAC we can say it is as ethanoic acid. In normally we can say, or commonly we can say it is as acetic acid. We have common names, you can have IUPAC names. In common names, we can name, if you have the single carbon, we can call it as a form. If you have 2 carbons, it's called acetal. So in IUPAC, if there is a single carbon, that is called meth. If there is a 2 carbon, it's called ether. So here, how many carbons are there? 1, 2, 2 carbons, which means you remove this, you can remove this stoichiometric coefficient, you can see only this one. If 1 carbon, 2 carbons. How many carbons are? 2 carbons. According to common name, if there is 2 carbons, it is called acetal. Hence it is called acetic acid. Acetic acid. Come to IUPAC. In IUPAC, if there is 2 carbons, it is called as ethane, right? Eth is called. So ethanoic acid. What this is? Ethanoic acid. So you just remember the common name. What is the common name? Acetic acid. You want to remember all these formula. What's the formula of acetic acid? The formula is CH3COOH. CH3COOH. He is the first scientist. In 1845, Kolbe synthesized the first organic compound from its elements in laboratory, that is by combining 2 moles of carbon with 2 moles of hydrogen and 1 mole of oxygen. He got CH3 2 moles of oxygen. 2 moles of oxygen, he got CH3COOH, right? I hope you can write like this 2 moles of O2, 2 moles of O2, right? I hope you understood, right? Now, actually there is no 2 moles here. We only has like this. So 2 moles of carbons, 2 moles of hydrogen, 2 moles of oxygen. On heating it, we can get CH3COOH. Here carbon gets satisfied and 4 hydrogens get satisfied and 2 oxygens get satisfied, and it's a balanced equation. Okay, and one more scientist also did, and he also discovered one more organic compound in laboratory. Not discovered, he prepared, he synthesized. All these are synthesized. Okay, these are synthesized unexpectedly. Okay, now I hope you got clear regarding this. Write the notes very properly and very means very detailedly. You can write each point. Each point is very important regarding organic chemistry. Why? Because after NEET 2025, they were asking simple things that we're not able to focus on them. So they are asking only basics that most of the students not focus on them. I hope in biology you can see about reductionist biologists. No one can focus on them, and most of the students also neglect all these topics. So who will ask about scientist test? Who will ask about these simple things? They will neglect. But now the India was majorly focused on these basic topics, with the students will mostly neglect. I hope you have understood. So write down all these things and practice it thoroughly. So when you practice organic compound, organic chemistry, you just keep one rough notes with you, and how many times you can practice, that much better you can do. Okay. Now, come to third scientist. I'm talking about third scientist. I hope you understood these two scientists. Come to third scientist. So the third scientist in 1856. The scientist in 1856 called Berthelot. In 1856, scientist called Berthelot, or the scientist Berthelot. So he was synthesized second organic compound from its elements in laboratory. All these fellows were synthesized in laboratories only, right? So why they were synthesized in laboratory only, the scientist named Berthelot's statement get wrong, right? Now, what he was synthesized means he synthesizes the methane gas. You know the methane gas, right? So it's a hydrocarbon. So what he done means he took a graphite. What are graphite? Carbon has a many isomers, right? It has diamond as isomer, it has graphite as isomers, like that. So graphite is one of the isomers of the carbon, right? One of the isomers of the carbon. So here carbon he took that is a graphite in solid form. What is it form? Graphite actually exists in solid form. Carbon will exist in many forms. Carbon dioxide, it is in the gaseous form, right? Here carbon graphite exists in solid form, right? Solid form. And as well as carbon diamond also exists in solid form. So he took carbon graphite, which is solid, and he combined it with 2 moles of hydrogen. And it is a gas. So when he heated it, what he done? Heated it. And what is synthesized means CH4 was synthesized. This is called methane. What is this? Methane, and it is a gas. It is called hydrogen. This is called hydrogen. You see here, this is called graphite, which means a carbon. And when carbon was reacted with 2 moles of hydrogen, it is in the gaseous form. And on rearrangement and on heating it, what was synthesized? CH4, which is called methane. It's one of a gas, and it's one of type of a hydrocarbon was synthesized. In laboratory. It is from its elements, right? Here CH4 has how many elements? 5 elements, right? There is a 1 carbon and hydrogen, 4 hydrogens. We have carbon and hydrogen. So here in reactants, this side is called reactant and this side is called product. In reactant we have carbon and hydrogen, and product we have carbon and hydrogen. Means this compound has elements that is carbon and hydrogen. So from its elements only the organic compounds was synthesized. And the second organic compound which was synthesized from its element is called the methane, and the first compound was the acetic acid, and first organic compound which was synthesized from inorganic compound, that is called urea. The formula is NH2 C double bond NH2 from ammonium cyanide. I hope you understand. This is about scientist traits, right? First we discussed about bacillus, later we have discussed about Fedrichol, third we discussed about Kolbe, and fourth we discussed about Berthelot. Very important what they have done, what is their contribution, and which year we have done. If they ask about math, the following question. We have 4 scientists, right? 4 scientists, what they have done. So if there is talk about bacillus, he proposed a VFT theory. If they talk about Fedrichol, they talk about urea. If they talk about Kolbe, talk about acetic acid. If they talk about Berthelot, you talk about methane. Like this, the following is very important. So now we discuss about what is how the carbon will form such much compounds. So carbon is the only element, it can form nearly crores of elements, crores of compounds. So actually carbon singly can form crores of compounds, but all the elements only form 60,000 of compounds. All elements can form only 16,000 compounds, but singly carbon can form 1 crore of compounds. So 95% of the compounds which are existed in nature, all are the organic compounds which are formed by the carbon. The remaining 5% only formed by other elements. So what is the reason of forming such a huge and massive amount of compounds by the carbon? There are the 4 reasons. What are the 4 reasons we can discuss now? Okay. So now only 30 minutes was completed. I hope you understand the problem. So in next class we can discuss about what are the reasons that the carbon will take as advantage to form such a massive compounds. And in next class we also discuss about how we can draw a line structure of a certain compound. Everything we can discuss. And in third class we can discuss about IUPAC. I hope you understood. So thank you. Keep subscribing the channel and watch the video and share this video to many of the students who is neighbors to you. Thank you.